Hello again, welcome to the second part of our video recording about the teleprotection of distance schemes, and our next part we will talk about the permissive underreach. So we will keep all the settings, all the configuration are the same as we did in the first part of the permissive overreach, but just we need to change the device configuration from here to be permissive underreach transfer trip with Z1P acceleration, and we will keep all the other settings as the same as we did in the first part. As you can see also here for the teleprotection. So I will use the same template of the permissive overreach, but now we will explain what is the main differences between the permissive underreach and the permissive overreach. So for example, the series of operation now for the permissive underreach, it will work only with the Z1. So the send logic will be working only if the device is picked up in Z1, not in Z1P as we saw in the permissive overreach, but the trip logic will be the same. So here is the main differences. So as you can see here, if the fault is outside the Z1, so the relay A will not send any carrier send from here, and it will trip with a time delay which equal to Z2 in this case, because the fault is in the successor line, which means is the reverse zone for relay B. So here is the main differences. Also, it's recommended to see the user manual of the Siemens 7SD522. So if you go for the permissive underreach transfer trip with Z1P acceleration, also you can see here the send logic and the trip logic. For example, here is the send logic for L1, L2, L3, or the general carrier send from here. So the device should be picked up in Z1, not Z1P. In permissive overreach, it was Z1P, but in permissive underreach, it will be Z1. Also, it has to be in the forward. Also, the teleprotection should be on, and there is no any block, and there is no any receive fail to send this carrier send to the other end. On the other hand, the trip logic here will be the receiving on channel 1, on L1 or L2 or L3 with the pickup of Z1B. So the trip logic is same for the POTT or for the PUTT, but the send logic is different. I hope this is clear, and also you can consult the series of operation from the user manual of the Siemens 7SD relay. Let us go directly for the template, and I explain the power system, the report, the overview in the first part. If you forget something, you can get back to the first video in our playlist. Also, here is the same configuration of the two CMCs with relay A and with relay B, and with the same configuration, and we are using also the same binary inputs. We have 3 binary input, one for the trip, the number 3 also for the carrier send, number 4 for the carrier receive, and then we can go for the test manager directly, and we can execute all the test plan. So now this instruction modules pop-up message tells us to deactivate the teleprotection. Now it's deactivated, so we can go directly to the time grading. Also, we can do a check wiring here to make sure the measurement of the current and the voltage is the same. And to check this measurement, you can go for the software or the DIGS software, or for the local HMI of the relay. Also, you can identify which CMC is connected to which end, which means this CMC is connected to relay A, and this one is connected to relay B, and there is direct sync between both of them using the Ethernet between the two CMC 500 as we explained in the first part. Then we can continue the test. So here is the first part, which is the time grading without teleprotection at different fault location as we explained before, and at different fault loops. So you can see the assessment now, automatic assessment for trip A and trip B, because this fault is at 14%. So 14% for relay A, it will be Z1 with instantaneous tripping, but for relay B, it will be Z2, which means 68% with in respective to end P. So the trip time will be 400 milliseconds, as you can see from here. At 26, both relays should be tripped with Z1. And here is another different location at 85%. So the relay 1 will be tripped with Z2, and the relay P will be tripped with Z1 instantaneous tripping. So we have different fault loops at each different location. Also, you can see here the send logic. You will not see any send or receive logic here because the teleprotection already off. You will find only the trip signals for relay A or for relay B. As you can see here, single line to ground, phase R. You can see also the current waveform for both ends, relay A and relay B. You see now we are receiving only a trip signal without any send or receive because teleprotection is off. So after finishing the time grading without teleportation, now the pop-up message again tell us to activate the teleportation. So I will activate it from the local HMI of both relays, and then we can proceed. So now both relays now activated the teleportation, so we can proceed with the test cases. So we have here double-infeed on the line at different fault location, different fault loops, and we will assess the trip time of A and B. For example, here at 0%, so the relay A will trip with Z1, but the relay B will trip with Z1B, which is almost delayed by 30 or 40 milliseconds. And you can see the difference of the trip time from here. But at 50%, both relays will see it in Z1, so it will be instantaneous tripping from relay A and from relay B, as you can see. And also now you can see also the send and the receive logic, so both relays will send a carrier send to each other at the same time, as you can see from here. Yes, for relay A and relay B. Also you can see the local HMI LEDs to make sure the carrier send and the carrier receive. Yeah. So here is at 100%. You can see now the relay A tripped with Z1B teleprotection trip time, and the relay B is tripped instantaneously. Then we have also again double-infeed and fault on the line with our fault. And also we have here different phase angles of the infeed B to simulate realistic scenarios and to get the trip time for all these phase angles and also for different fault loops. So all this test point in this test case at 100%, so the fault location here is fixed. So the relay A will trip always with Z1B teleportation trip time, which is 78 or 68 milliseconds, and the trip B on the other hand will be tripped with Z1, which is instantaneously tripping. Then here we have a single infeed A, so there is no any infeed coming from infeed B. Also, you can see the current waveform here for both cases. So you will find the relay P current is almost 0, which means there is no any infeed from the other side. However, there is another function covered this scenario, so which is called weak infeed, with two mode. One mode is echo. If it receives, the carrier receives, it will send it back to the other end, and the other mode will be echo plus tripping. So it will send it back, and circuit breaker will be tripped in the same time. But this is not our topic today, the weak infeed. We can cover it in different videos. Also here we have a single infeed coming from P, which means the infeed A current is 0. You can see it from here, the relay A current, but the relay B will be available for different fault loops. Also you can see the values of the relay B current from here. If you click the multimeter, you can see here the relay P values, where the relay A values will be almost 0. As you can see, IL1, IL2, IL3 is 0 for relay A, and for relay B it will have a value for 3-line fault with different slip angles. Then we have this test case, we have a single infeed, but the fault will be in Busbar, which means there is no any teleprotection tripping here. So the relay A will trip with Z2 equal to 400 milliseconds. The relay B will not send any carrier send to the other side because it's reverse, and it will trip with Z3, which equal to 819 milliseconds. You can see also there is no any send logic from here. You see, there is no any send from relay B because the fault on the reverse line or the successor line. The same test case also, but the single infeed is coming from B side, and the fault on busbar A. So the relay A will trip with Z3 reverse zone 819 millisecond, and the relay B will trip with Z2 equal to 428 millisecond. Then we have the double infeed, also the fault on the busbar. So we will see here double infeed from infeed A and from infeed B, and here is a fault on the busbar A. So we are expecting the relay A to trip with Z3 827 millisecond, and the relay B will trip with Z2 448 millisecond, whatever the infeed phase angle or whatever the fault loops, because the fault on the busbar A. So here is the number of test steps: 21 here, executed is 60 right now, failed is 0. Also the overall progress here, you can see the overall progress from here with the timestamp. So we have 3 stages for each test point. We have calculating signals. So the RelaySimTest will calculate the corresponding signals for this test point. Then it will upload the signals to the software. Then it will inject the signals using the CMC 500. Here is the last case. We have double infeed, but the fault will be on bus P, which means relay A will trip with Z2 400 millisecond. Relay B will trip with the reverse zone trip time delay, which is 800 millisecond. Yeah, it's very simple, very straightforward. Now we have 66 test point executed from 71. Here is the overall progress. Here is the countdown for the time. So we have 30 seconds to finish the test. Okay, it seems very easy, very straightforward. As you can see, we finished it in very short time, and I would like to give you one recommendation here about the configuration between the two CMC. So if you are working in end-to-end real-life scenarios, which we have one CMC for substation A and the other CMC for substation B, so we can use the CMGBS588 as a BTB time source to synchronize both the CMC at both substation ends, and then we can go forward for testing all these test cases. At the end of the day, you can see here is a report from here. Also, you can change the title of the test file from here. So we are working now with the PUTT, Permissive Underreach. Then you can export the Word file from here. It's very straightforward. Yeah, so here is a test result. You can compare it with the permissive overreach. You can do the math, do the analysis for each and every single test points. So it's very easy, very straightforward. So here is the end of our second part of the permissive underreach with Z1P acceleration. So the next part we will be working on the blocking schemes. Thank you and see you soon.